Hi, everybody. We're going to get started very shortly. Thanks all for coming. Thanks for your patience here. It's going to be a really exciting workshop. We're going to go over introduction to Chainlink. So this is going to be a great one for those of you learning about Chainlink and learning about the technology for your hackathon project. So really excited for this one.
Hey everyone, welcome to the What is Chainlink Hackathon workshop. Super excited to be here. Let me just share my screen real quick. There we go. So the fact that you're here may mean you are already familiar with what Chainlink is. But if you're not, don't fret. That's why I'm here. We'll have a fantastic workshop. So, if you don't know me, a little bit about myself. My name is Zach Ayash. I'm a developer advocate at Chainlink Labs. And a quick background on my Web3 history. So, back in early 2017, I fell in love with blockchains and smart contracts due to the very reasons Patrick Collins so eloquently described in his presentation. I really loved how they let us rethink how we approach agreements by utilizing mathematical guarantees. At the time, I was researching, falling down the crypto rabbit hole, and my research led me to Chainlink, and I loved the fact that the protocol solved such an important problem that really makes smart contracts truly useful. So I had a goal to work supporting the Chainlink protocol. So I taught myself programming. I was a mechanical engineer at the time. And now I get to help others like yourselves learn how to program in this industry and create powerful hybrid smart contracts. Now, if you don't know what that means, don't worry. We'll get to it later in the presentation. So thanks again to the previous speakers, Patrick and Solange, for laying the foundations of what blockchains are, smart contracts, why they're important, and programming and Solidity. Those presentations were extremely useful. And with that knowledge, we're going to take that and we're going to dive in to what Chainlink is. And yeah, hey everyone. Thanks for the support in the chat. So before we dive into Chainlink, let's go back into blockchains. So blockchains are deterministics, and this means they cannot connect to the outside world natively. Why are they deterministic, and why can't they connect to the outside world natively because of that? Well, in one word, consensus. Remember, blockchains are comprised of many nodes all over the world, and they have to agree on every calculation that they run and on the state of the blockchain. They have to reach consensus on what the blockchain is. So on the left side, we have an example of this like 3-node blockchain, like a 3-node Ethereum blockchain, and it's deterministic. And on the right side, we have an example of a blockchain that maybe have this ability to connect to outside data sources, and it's not deterministic, and this is bad. So let's walk through why that might be. So if you look on the left here, each of these nodes is calculating 1 plus 1. Now, the last I checked, 1 plus 1 equals 2. It's really easy to agree on that in math. And so each of these nodes calculates 1 plus 1. They get 2. They communicate with each other. They say, hey, 1 + 1 = 2. We're good. Consensus is reached. We know what the state of the blockchain is. On the right side, we have this blockchain is connecting to an API, which is programming speak for a data source outside of the system, right? And perhaps this data source is giving the data of an asset, say a cryptocurrency like the price of Ethereum in terms of USD, right? And so you may know cryptocurrency prices can be quite volatile, even second to second. And so the node on the bottom left here sends out a request to the API and gets an answer of, say, like $2,000. I don't know what the actual price is, but as an example. And the top node, then a couple seconds later, because remember, these nodes are spread out all over the world and may get these requests at different times. It sends a request out to the API and gets an answer of $2,000.01 because it sent out the request a couple of seconds later. Well, now we have one node saying 2,000. Now we have another node saying $2,000.01, and they can't reach consensus on the state of the blockchain, and the blockchain fractures and it breaks. This is obviously not good. This is not what we want out of a blockchain. So this is why blockchains and smart contracts cannot connect to the outside world natively. We're stuck creating smart contracts that are only aware of the internal blockchain state. So essentially, we can represent ownership of digital items, and that's about it. Or is it? Another name for the smart contract connectivity problem is the oracle problem. So why oracle? In Greek mythology, an oracle was a person who was connected to the gods, was their voice, and essentially knew basically everything about how the world worked and could relay information from the gods to humans. So blockchains need some kind of oracle that can relay info into smart contracts about the rest of the world. Is this possible? It is. Enter Chainlink. Why we're all here. It's a protocol for building decentralized oracle networks. In this context, a oracle is middleware that sits in between blockchains and the real world. And it relays information about the real world into blockchains and smart contracts, and relays info about blockchains and smart contracts back into the real world. So it works both ways. And in programming, we call this middleware. So again, it sits in between blockchains and the real world and is its own system. So what is a simple way to design an oracle? You could use a centralized node. Let's say you're making a financial contract that needs to know the price of ETH in terms of USD. Again, so you have a friend, Alice, and she's a big trader, and you know she really keeps up with all of the big crypto, the latest cryptocurrency prices. She knows all of the exchanges, ETH is traded on, and all of the big data providers. And so you trust Alice to put this ETH USD data into your financial smart contract. Well, remember from earlier talks, blockchains get all of their useful properties because they are decentralized, right? This is what makes the magic happen. And we're using a centralized node to communicate information into the smart contract. So this kind of defeats the whole purpose of blockchains to begin with. A centralized node defeats everything. Alice could be hacked. She could be bribed. Simply go offline because her internet provider goes down. To Alice. And excuse the pun, now there is a weakest link in the chain, right? And when there's a weakest link in the chain, that link will be targeted by attacks. And this happens all the time in current Web3 ecosystem. Systems that have used centralized oracles have been hacked and lost a lot. So the answer to this is we need some kind of decentralized Oracle network. And Chainlink is designed to be a protocol for building modular decentralized Oracle networks for whatever kind of data may be needed for smart contracts. And because it's decentralized, it preserves all those awesome properties that we love about blockchains and what makes them useful. So we can bring data in or trigger external computation in a decentralized way. By doing this, we solve the Oracle smart contract connectivity problem by extending decentralization and trust minimization of your smart contracts out to the data delivery and data source layer. DONs can be DONs, decentralized Oracle network. So from now on, I'll be shortening those to DONs. They can be built with as many or few nodes as needed, and really every aspect of the DON can be customized for the data that is being delivered to the smart contract. So DONs can even have their own form of consensus, kind of similar to how blockchains need to reach consensus. And in data feeds, which we're going to talk about in a bit, this is called aggregation, right? So in this diagram, you see a bunch of nodes. And again, they're getting the price of an asset. Let's say maybe it's Tesla stock this time. And they're all communicating with each other, and they post all of the points of what they think the price of the asset is on chain. But in the end, all of this is aggregated into a single data point, a single source of truth for what the price of that asset actually is. And going forward, you'll see oftentimes for especially price data, the aggregation is often a median. But this can be, again, changed depending on the needs of the DON, decentralized Oracle network. So by combining on-chain contract code with off-chain resources and oracles, we now have defined a new type of smart contract. What I mentioned way at the beginning of the presentation in my introduction, hybrid smart contracts. These are smart contracts that rely on existing on-chain code and combine it with off-chain components like data and computation. And these hybrid smart contracts really bring the true original vision of smart contracts to life. And they're already kind of redefining what Web3 and what everything we're doing is about. And they'll continue to bring new functionality and take smart contracts to new heights. So building a DON sounds like a lot of work and responsibility, right? I mean, you have to make sure that the system is extremely secure and delivering high quality data to smart contracts at all time. And this is what Chainlink data feeds are for. They are pre-built DONs that are already gone through all the battle testing and have a history and reputation of delivering secure, high quality data to blockchains for you to use in your smart contracts. And Chainlink data feeds are already securing over $76 billion in DeFi, which stands for Decentralized Finance. So DeFi, decentralized finance, is currently one of the most popular use cases for decentralized Oracle networks built with Chainlink, and a great example of what we defined earlier as hybrid smart contracts. So DeFi takes traditional financial apps such as borrowing and lending and exchange of currencies and makes them decentralized smart contract applications, right? So dApps now. For these DeFi smart contracts to operate effectively, almost all of them need to know price data of assets, right? Whether that is of cryptocurrencies themselves, because blockchains don't actually know what the price of cryptocurrencies are in these markets outside of the blockchain, right? Could be the price of, again, stocks, right? Or even gold and like physical assets out in the real world. So to help bootstrap DeFi and the Web3 ecosystem, Some of the best node operators in the industry have combined their skill and experience to build what are called reference contracts. These are smart contracts that Dons deliver decentralized data to. So then you can reference these reference smart contracts to get this price data into your own smart contracts. And these can really be considered sources of truth for various currency pairs. Again, I'll go back to that ETH in terms of USD, for example. So if we look at the diagram in this slide here, we'll see that we have on the left exchanges. Then we have the data providers that are aggregating all of the price data from these exchanges. And then we have these Chainlink nodes right here. And each one of these nodes can connect to multiple data providers and even the exchanges directly to aggregate price data for these price pairs at the node level. So each individual node wants to report the right price, right? They don't want to be an outlier in the DOM. So each node aggregates the price data individually and then communicates with each other. And as we showed earlier, the data is aggregated between the nodes, and that's put on chain in these reference smart contracts. So see, we have a couple of questions. I'll look at it. Is building our own DON a thing, or how do we use the same thing in the Chainlink ecosystem? Yeah, it's totally possible to build your own DON. So Chainlink, everything is open source, and you can look at the source code for running a Chainlink node. There'll actually be a workshop later in the hackathon for running your own Chainlink node. But remember, creating a DON does require a good amount of work and responsibility. So that could be a lot, but you can do it. And it is all open source. So there are projects that have built their own DONs. Let's see. How's verification done if there's only one source of data and that itself is providing false data? Well, if there is only one source of data, then that would become the source of truth for that data, unfortunately, right? Like, if you're the government and reporting on data that's exclusive to only that government, then you are the source of truth for that data. Now, you could work on creating decentralized data sources for that source of data, but either way, you're going to want the delivery layer of that data to be decentralized, right? So perhaps it's still centralized data, but you don't want centralized data delivery to a decentralized blockchain. At least at this, with the decentralized Oracle network in between, you can be assured that layer won't be compromised, and the only layer you have to worry about then is the centralized data source. All right, let's go ahead and move on to the next slide. So we can view these DONs on data.chain.link. If you just want to see them live in action and see what I'm talking about, we can go there. So let's go ahead and check it out. All right, so here is the data feeds website, and as you see, it just takes us automatically to the most popular feeds, recent feeds. There's a search, and we can look at the different networks that Chainlink data feeds are currently live on. We'll go ahead and just click on this ETHUSD feed, as I've been talking about it throughout this workshop. And here we can see all the nodes that are reporting data to this feed and the prices that they are reporting. You see that final aggregated answer I was talking about, and these things called trigger parameters, right? These determine when the feed updates, and these can be customized from feed to feed. So we have the deviation threshold, which says, hey, if the price of ETHUSD changes by more than 0.5%, put an update on chain. And the heartbeat shows the maximum amount of time that can pass before a update is automatically posted on chain, regardless of how much the price actually changes, right? So There's 27 more minutes and 20 seconds until the next update is put on chain. We can see in the last update, 31 out of 31 of the oracles responded. And you can go down and see all of the on-chain addresses, ENS, the history of the answers of the price data, and go look into each node in a little bit more detail individually. So this is a really cool resource if you just want to see what data feeds are doing, see them live, and we'll talk about using these in your smart contract later in the workshop. So we'll switch back to the presentation. So Chainlink data feeds give you full market coverage of both decentralized exchanges and centralized exchanges. Again, they can mix premium data providers and aggregators along with actual exchanges. They can use techniques such as volume-based average method of aggregating data, which is a very, very good way to aggregate price data for assets, right? So in this case, if you have an asset that is basically all traded on Coinbase, for example, or Binance, you really want to weight the price data coming from that exchange more heavily because that's basically where all the price discovery is coming from. The feeds are live on multiple blockchains, as we saw earlier, and most of the feeds are now upgraded to use OCR, or off-chain reporting. And what is OCR? So in OCR, that example I went over earlier, that image, that's actually an image showing the process of off-chain reporting. So each node is communicating with each other over a peer-to-peer network, much like blockchains nodes do. Each node, aggregates their own price data and signs the final value they deem to be the actual price of the asset. This report is passed around between all the nodes, and a single node is elected as a leader and posts the full report with all of the signed data transactions from each of the nodes on chain. The aggregation is still done on chain, so maybe again it's taking the median of all those data points, and by simplifying it to a single leader posting the data, this reduced gas costs up to 90%, which is extremely, extremely important in blockchain world, especially in a blockchain like Ethereum, where block space is in super high demand. You don't want to clog up the blockchain with all Oracle reports, and then you want to actually have space to run actual DeFi transactions. So this is definitely good for the whole ecosystem. And so before we move on to talking about Chainlink VRF, I'll see if there's any other questions. Okay, so how does the penalization system work for a node providing biased data? So there's a bunch of crypto economics around what's called implicit staking, and you can read more about the crypto economics of the system in the Chainlink white paper. But essentially, as nodes post data on chain, remember this is all visible. It's all there. So if a node produces an extremely biased report compared to other nodes in the Don, it'll be visible on chain, and this will severely hurt their reputation and the ability to get future revenue from the Don. They may even get kicked out of the Don. And there is a system in the work called explicit staking. And again, you can check out the Chainlink white paper 2.0 for a little bit more detail on how that is planned to work. Is the aggregated result the mean of all the values or the most agreed answer? This could be, again, customized from Don to Don, right? For most of the price data, it's the median, and this is good because averages are extremely susceptible to outliers moving that average out. So a median can be a better, more secure data source to use. But yeah, you could use like a mode or the most common answer if it was like maybe like a Boolean, like 0 or 1, true or false kind of thing. It's really up to the need of the smart contracts requesting data from that DOM. But if updated each hour, not real time at all. True, we could have a DOM that is updated in real time. Like you could have it minute to minute if you wanted, or second to second. But most smart contracts don't need that. And again, a custom DOM can be built to do that. But remember, because these nodes are doing all this work, they're actually getting paid in link token behind the scenes. And this can get quite expensive for the smart contracts getting this data. Or the smart contracts that are hosting these DOMs. All right, see if I'll do one more. Is Chainlink a DOM itself, or is it an ecosystem of DOMs? Great question. It is an ecosystem of DOMs. So again, if we go back to that data.chain.link, we go to data feeds here. These are each their own unique DOMs, their own decentralized Oracle network. So we have the ETHUSD DOM, and let's click the DAI-USD DOM, and this has its own nodes on the data feeds page, right? And so when you see it has its own parameters that are special to that DOM. So yes, it's an ecosystem of DOMs. Let's go ahead and move on then. All right, so Chainlink VRF, which stands for Verifiable Randomness Function. Due to the deterministic nature of blockchains, again, that prevented them from getting data from the outside, blockchains and smart contracts are also bad at generating randomness, right? Deterministic is kind of the opposite of randomness. So until the Chainlink verifiable randomness function, VRF, getting random numbers on chain has been an issue. There was kind of old ways of doing it, which you would have to rely on chain things, such as an on-chain hash, or again, connecting to a centralized API that can be hacked, bribed, go down. And even if you use the on-chain metrics, this can be gamed and biased by miners, which can influence the randomness so it benefits them. And exploits have happened there. And again, because the randomness is generated on chain and everything on chain has to be deterministic, essentially miners can predict what the randomness will be. And that's how they can bias it in their favor. So what Chainlink VRF does is it provides a random number alongside a cryptographic proof that proves that the number was indeed random. The cryptographic proof and the random number are verified on chain in a smart contract. And again, this provides provably random and secure randomness to smart contracts. Now, why is this important? VRF allows provably fair outcomes in things such as games. Now, you may think gaming isn't that big of a deal, right? But it's important to the people who participate in those games, just like crypto is important to you as a person who may participate in getting cryptocurrencies, right? You can give the users and the players of this game true guarantees that if something is meant to be random or have a certain probability of happening, that is indeed that probability and truly random for happening, right? So as an example, you could have an NFT trading card game, right? Where there's booster packs for NFTs and you have this ultra rare NFT, 1 out of 10,000 chance of getting. And now users are assured that they truly have a 1 in 10,000 chance of getting that ultra rare card, and no one, not even the creators of the game itself, can bias that result to benefit someone else. Run some kind of scheme. Um, Selecting lottery winners is truly important to assure that if you're running some kind of lottery or raffle on the blockchain, that the statistics of winning that raffle are truly random, and the probabilities line up to what is advertised, right? So that's Chainlink VRF, bringing provably secure randomness on chain. So, a kind of theme here is limits of smart contracts. We talked about Chainlink data feeds, and just in general why smart contracts and blockchains can't connect to outside data sources, randomness, and Chainlink Keepers illustrates another limit of smart contracts. They can't actually execute their own code without an external actor running that code. So in Solange's demo, you saw her writing Solidity code, deploying that code in a smart contract to the blockchain, and running functions, right? But every time she wanted to run a function in that smart contract, she had to run it herself from her own wallet. And Chainlink Keepers allows us to automate the running of functions, and of course, in a decentralized way, preserving the properties of blockchains and smart contracts. So again, we have a dawn of Chainlink nodes, and this time what they're doing is monitoring the blockchain, waiting for a condition set by you, the developer, to tell them when they need to run specific functions. So an example of where this could be used is, like, let's say, adding another security level to liquidating DeFi loans, right? Almost all DeFi loans are currently required to be over collateralized, which means there needs to be more value in, say, like USD of collateral versus how much is taken out. And if that collateral falls below a certain threshold of value in USD, then that loan needs to be liquidated. The collateral needs to be taken out. That loan needs to be canceled, right? And of course, that price data coming on chain is coming from a Don. But in the past, these liquidations, are open and they can be done by anyone, which is good. But if you have a certain sect of loans that aren't exactly being monitored, or gas prices spike and people are hesitant to go through and actually liquidate these loans, the systems can break. And so you can make a job for the Chainlink Keepers network to monitor those loans, and if they fall below a certain condition, liquidate those loans. You could also have something like a time-based smart contracts, where a function is run every day or every hour or even every minute. So you could have a lottery that just automatically runs every day, noon Eastern Standard Time, right? And be assured that it will run. And the automation of this, again, is decentralized. This is super important. So we preserve all these awesome properties of blockchains and smart contracts. So let's see. Let's go over some questions again. How much is it to generate a number with Chainlink VRF? So the price of Chainlink VRF is set depending on the needs of the contract requesting the number, right? It's actually important. It's dependent on a bunch of different factors. So Chainlink VRF now, it's actually in V2 of its versioning, right? And with V2 came a subscription service where you can tell it, how fast you want it to respond, if you want multiple numbers. And we can take a look at this later in the workshop if we have time. But it essentially really just depends. And then the faster you want it, the more random numbers that you want per request, the more expensive it will become. And the docs kind of walk through all of that. So basically, Chainlink Keepers is a cron job. Yeah, exactly. That's a great analogy to what Chainlink Keepers are to the Web3 world. Hey, Mohammed, hard to keep up. Yeah, sorry, trying to squeeze this all in time. I'll try to slow down. And, we'll have more time to answer questions at the end. So hopefully that'll make it a little bit easier. Seems like there are several oracles with different costs. Yeah, every service incurs different loads on the Chainlink nodes and has different costs. When we go check out the docs here in a sec, you'll see that they walk through what these costs may be. And these these are set per DOM, right? What the cost could be. In case of data aggregation, are Chainlink nodes grabbing the data from different sources / data feeds and obtaining a consensus average other for final exposed value? Exactly. So again, back to the data feeds, they are grabbing data from different data sources and different exchanges. So they are then aggregating themselves. Each individual node gets an aggregated answer. And then the data is aggregated between the nodes for that final answer. So you can verify what a contract is supposed to do, but how can you verify that keepers trigger when they are expected to trigger? You can look on chain, right? And you can have require statements that make sure that it's not executed before it needs to. So put the same conditions for running the node as a running the keepers network as a require statement, which basically prevents it from running before. So beforehand, exactly. Yeah. So you would put like some kind of require statement that says, hey, if this value isn't set to true, like if enough time hasn't elapsed, don't let anything run this method, right? And what if someone hacks an API? So this will be the last question before we move on to the demo. So that's why we have all of these decentralized, and in the terms of data feeds, they're getting their data from almost every source that they can, right? So it's not reliant on a single API if that's feasible. So the last service I want to talk about real quick before we move on to the demo is any API. So like it says, you can connect your smart contracts to any API. But this is a centralized solution. I want to put this out there. So it is not recommended for production, but can be great for testing out a proof of concept for data that might not be available for a DON, but you just want to see if the concept holds any ground. It's fantastic for hackathon projects. So please look into the documentation for running any API. I have a feeling this will be very useful going forward through the hackathon. And we have the Chainlink Market, where you can, for any API, find a bunch of nodes that are listing their services and the jobs that they run, right? So, a node can go and say, hey, I connect to CoinGecko and I get the price data of this asset, and that's the only thing I do. Or if you have some programming knowledge, I can connect to, you can customize, you can tell me what open API to connect to, and I'll make a GET request and post that response on chain for you. Or instead of using one of the nodes in the Chainlink Market, you can run your own node, which I recommend. And again, there will be a workshop later in this hackathon showing you how to run your own node. It's really not that bad, and it's a great learning experience. So I really do recommend, if you can and you're using any API, to run your own node. All right, we're running on time, so I'll try to keep these question sections short so we can get to the juicy bits. Can a keeper check several data feeds at once? Yep, you can customize the keepers to like send a request and tell them to look for whatever it is you need that is on chain. Can you run into a consensus problem if there's an even number of nodes? Maybe a remote case, but it's possible. Yeah, and the logic you could just have, if it's like a median, there's like standardized ways to handle that. If there's not a single answer in the middle, you average the two that would be around where the middle data point are. This again can be customized down to down. Okay, so let's dive into the demo. We're gonna go into the Chainlink docs, and we're going to deploy a contract that uses Chainlink data feeds. And if we have some time, I'll go through. It's not looking like we'll have enough time, but I can show you where all the other resources for each of the other services we talked about in this workshop. All right, so let's go ahead and go to the docs. So, in this hackathon, I really recommend you get in the habit of going to the docs. A lot of work has been put into them, and they really walk through all of the Chainlink services in detail and should answer almost all of the questions you have for those services. So if we scroll down, we're going to deploy to EVM chains. We're going to deploy to Ethereum itself. And we're going to click on data feeds. So we're going to go to the data feeds service. And you'll see an introduction kind of explaining data feeds like I explained earlier. And if you scroll down on the left nav bar, you'll see randomness, that's VRF, connecting to any API, which is the any API service, and automating smart contracts, this is Chainlink Keepers. So we'll click on using data feeds, and you're going to see this example of this explanation of data feeds and how to use them. But if we scroll down, you'll see this example code for how, if you're writing a smart contract, this is an example of how you could write one to make your own contract that uses price feeds. If you keep scrolling down, you'll see a button open in Remix. So Sol walked through Remix in the previous demo. So I won't go through explaining Remix and what it does. But if we click open in Remix, it pulls this up. And when it's done loading, boom, we have that exact code that we saw in the docs and put into Remix. So if we look here for this contract that's utilizing data feeds again, we have a single import. We're importing the aggregator v3 interface.sol, which is the sole import you need to use data feeds. Now your contract is able to use data feeds. And so we have our constructor, which sets and points to the data feed we want. In this case, it's pointing to the ETH USD data feed that's live on the Coven Ethereum testnet at this address. So we see that right here. Let's set it up in the constructor. And we have a single function that gets latest price. So it gets the latest price of ETH in terms of USD. And what it does is it calls our price feed and it calls the latest round data on that price feed, latest round data function. And latest round feed actually returns, latest round data actually returns a bunch of return values, but all we need is the price. So that's why the rest of these are commented out, except for the comments here. So let's go ahead and deploy this. I'm going to minimize this real quick so we get access to my MetaMask. Well, we're going to switch to Coven. And real quick, need to put my secure password into MetaMask. No wonder I had caps lock on. Secure passwords. Important. Can be a hassle. All right. So I have some testnet ETH. I'm connected to Kovan, which is where we're going to deploy because that is the Chainlink price feed we are pointing to. We'll go here. Looks like everything is compiling fine. We'll go to the deploy. And we're going to switch it to injected Web3. So we're going through MetaMask to deploy our networks, to deploy to the networks. It's pointed to my account. You see that 0.55 ETH that I have here in my MetaMask. And this is the tricky part. Make sure you point to price consumer v3. So this is pointing to the import by default, which Remix tends to do. And I do this all the time. I deploy the contract and there's nothing there. And that's because I deployed the import. We want to deploy the price consumer v3, which is this contract we're looking at. So we'll click deploy. And a MetaMask will tell us the gas. We'll click confirm. Since this is testnet, this is all funds that I've gotten from a faucet. It's not real cryptocurrency funds. Be very careful if you're doing this on mainnet and using real funds, as always. And if we look at the deployed contract here, we have one function, right? That get latest price function. And if we click on it, fingers crossed, it should return the latest price. Boom. So we clicked on it and return the latest price of ETH, which is like $2,959. So Solidity doesn't really do decimals. There's another function you can call that returns where the decimal point is if you're curious. But this is the latest price of ETH in our smart contract. And now we could go through here and customize our smart contract to do interesting stuff with that price data. So maybe we return it and then it runs it, through some, it's an exchange and uses that price data to determine what exchange rate the various currencies should be at, all kinds of different things we can do. And so since we're running on time, there's not enough time for me to go through and walk through all the code of using each service. But again, the steps are very similar to what I showed you before if you just want to get a start. If you want to go to VRF, you can read an introduction about it here, complete with this awesome video, support a network. It explains that subscription model that I talked about earlier. And you can go to get a random number where it'll explain step by step how to create, fund a subscription, and use random numbers in your smart contracts. Same for any API. We have the awesome deployable code so you can take a look at it and mess around with it yourselves, and keepers. So with that, so we've talked about the Oracle problem in this presentation. We went through talked about the various Chainlink services, data fees, VRF, keepers, any API, and we built and deployed our very own hybrid smart contract. And that was a hybrid smart contract that we put on there using price data. Once you've done that, you deploy your own hybrid smart contract. You're already a Web3 developer. You've developed your own smart contract and deployed it. It's that easy. Chainlink docs are actually one of the first places I started when I learned how to code in Solidity, right? Because I love those deployable examples. Some other resources, if you're not already familiar. Of course, the Discord chat is a great place to go and talk to other developers that are in the hackathon and the community. Some of us dev advocates go in there and check some of the questions during the hackathons. We have our starter kits, which will have a workshop for each one of them after this, later in the hackathon. The documentation, like I talked about earlier, and the Chainlink Academy, which is a new resource, still kind of building up its repertoire, but can be a place to learn some of the very basics. I'll look through, see if there's any last questions on the last couple of minutes here. Once you have your own custom API hosted as a Chainlink node, this is one source of the data. You can then try to create relationship with DOMs to get your nodes included in their network. Exactly, Paul. Currently, you could create your own DOM. The pre-built Chainlink DOMs that you saw on the Chainlink data feeds, those are really vetted for maximum security, reliability, to make sure they have the highest quality data. And once you run that node, that's definitely the first step you're going to want to take. Then you want to make sure you're following DevOps, best practices, making sure your node is always up, it's always running, it can survive all these crazy on-chain events. And then you can try to get in contact with some of the node operators and see if your node is up to snuff to join their DOM. And real quick, how does an import statement work? Where is it pulling the imported file from? Let's see if I can quickly switch to So in this case, it's taking it from an npm package. That's what the @ means here. And Remix automatically has the ability to sense that, hey, like this is @ it's pointing to this package, and it knows to pull it in for you. So in this case, that's where it's coming from. Yeah, so yep, thanks everyone. We're running on time now. There is this feedback form, if you could fill it out. Let's see, let's get it, see if I can get it. From the current slide, no. Okay, well, if you could fill out this type form and give us feedback on how this demo went, if I was going too fast or you would like more time spent on a certain subject, love to hear the feedback and see how I can improve going forward. Thanks for watching. Thanks for following along. I'll catch you around the hackathon. I'm super excited to see what y'all built, what y'all will build. And going off of what I've seen in previous hackathons, there's been a lot of awesome projects that have come out of this. So best of luck. Don't get discouraged. Just work it through. If you don't have any project to submit at the end, don't worry. Just work and get something out there and submit it. You don't have to win. This is how I learned. This is how a lot of people learn. Y'all got it. Thanks again, and I'll catch you around in my next workshop. See everyone.